difference between electrovalent, ionic and covalent compounds. The difference between ionic and covalent compounds can be determined by taking the examples of sodium chloride and chlorine gas respectively. First of all, let us see the definition of an electrovalent or ionic compound as well as a covalent compound. Electrovalent or ionic compound. The chemical bond formed between a metallic element like sodium and a non-metallic element like chlorine by the transfer of electrons is called an ionic bond. And the constituent ions bonded together by ionic bonds are called ionic compounds. For example, sodium chloride NaCl. Covalent compounds. The chemical bond formed between two non-metallic elements like chlorine by the mutual sharing of one or more electrons is called a covalent bond, and the constituent compounds are called covalent compounds. For example, chlorine gas Cl2. Due to the presence of ionic bonds in NaCl and covalent bonds in Cl2 molecules, there is a significant difference in their properties. There are 5 major differences that we will study. 1. The state of aggregation or physical state. Ionic compounds are usually crystalline solids. For example, potassium sulfate K2SO4, calcium chloride CaCl2, etc. Whereas most of the covalent compounds are liquids or gases at room temperature. For example, carbon tetrachloride CCl4, carbon dioxide CO2, etc. However, some of the covalent compounds are solids as well, for example, glucose, sucrose, etc. 2. Solubility in solvents. Being polar in nature, ionic compounds are soluble in polar solvents only. For example, an ionic compound like NaCl is soluble in water, which is polar, whereas it is insoluble in non-polar organic solvents like toluene. Polar covalent compounds also dissolve in polar solvents. For example, hydrochloric acid dissolves in water, which is a polar compound, while the non-polar covalent compounds dissolve in non-polar solvents only. For example, carbon tetrachloride CCl4 dissolves in a non-polar solvent like toluene. 3. Melting points and boiling points. In an ionic compound like NaCl, the constituent Na+ and Cl- ions are held together by strong electrostatic forces of attraction. Hence, ionic compounds tend to have higher melting and boiling points. On the other hand, in covalent compounds, for example, chlorine gas, the constituent chlorine molecules are held together by comparatively weaker intermolecular forces of attraction. As a result, covalent compounds have comparatively lower melting and boiling points as compared to ionic compounds. 4. Electrical conductivity. Ionic compounds conduct electricity when dissolved in water. For example, when NaCl is added to water, it dissociates into its constituent Na+ and Cl- ions, whereas non-polar covalent compounds like carbon tetrachloride do not dissociate into ions. Therefore, they do not conduct electricity and are called non-conductors. However, polar covalent compounds like HCl, when dissolved in water, behave as good conductors of electricity because they easily dissociate into ions in the solution. 5. Nature of component particles. Ionic compounds like NaCl are made up of oppositely charged ions, that is, Na+ cations and Cl- anions, whereas covalent compounds consist of electrically neutral discrete molecules like chlorine gas, Cl2.